Another type of function that you should be very familiar with is a quadratic function, and they are of the form of y equals x squared. The highest power of x is 2, so you can have y equals 3x squared plus 2x plus 1. That's a quadratic function, so as long as the highest power of x is equal to 2, no more than 2, it will be a quadratic. If you don't have a highest power 2, it's only 1, it'll be just a linear function. So you must have the highest power in the function that's being equal to 2. So we need to be familiar with what these graphs look like. So y equals x squared, I think you should be familiar with that. Simply just a parabola that goes through 0, 0. So that's y equals x squared. Now what happens if we make it y equals negative x squared? How does that change the graph? That means that y has to be negative everywhere. If you've got negative x squared, not negative x all squared, but negative x squared, y has to be negative everywhere. So that just flips the graph upside down. And this is y equals negative x squared. What happens if we change the coefficient of x squared and make it into a positive value? So y equals, say, 2x squared. Well, that's going to steepen up these two sides of the parabola. So this is still go through the origin. So that's y equals 2x squared. And a half x squared will open it out, so you get a much more shallow parabola as you make the coefficient between 0 and 1 a fraction. So 1/8 x squared would be quite shallow. So that's the coefficients of x squared. Likewise with down below here, if we put a numeric value coefficient there, it'll behave like what we've got up there. To move the basic graph up and down, so we've got y equals x squared plus 3. So we start off with our basic graph of y equals x squared, and we move it up 3 units. So 1, 2, 3. So this point here now becomes up there. So we get the graph moving up the page 3 units. Now we get vertical movement, so if it's -3 it would move it down to here and we would still have the same orientation as opening towards the top. That's vertical shift, vertical movement. We can get a sideways movement or horizontal shift by doing y equals x squared. Now instead of x squared we put something in brackets squared, and if we go say y equals x plus 2, now what is that going to do? The plus 2 moves it in the opposite direction to where you think. Now plus 2, the plus is going this way, so y equals x plus 2 all squared is actually going to move the y equals x squared. So there's my y equals x squared. It's going to move that in this direction. So if it's plus 2, it'll move it out to there. So the plus 2, if it is minus, it actually moves it to the right. So instead of having it like that, the -3 will move this out 3 units, and we get a graph that looks like that. So this will be out 3 units to the right. The way to remember that, whether you go left or right, is right at this spot, y is equal to, at the point 3, y is equal to 0. So when you look at that, you can say, okay, if y is equal to 0, what value of x will make this equal to 0? Because we've got to get 0 inside there. So if this is 0, y is equal to 0, And the only value of x there that'll make that equal to this bracket equal to 0 is x equals 3. So that must be where that is. If we go back up to this one here, and we're not too sure, what value of x will make this whole bracket equal to 0? And the only value of x is -2. So therefore that is going to be down here at -2. Alright, so putting it all together now, if we had y equals negative x squared plus 4, what is that going to look like? Draw some axes. Y equals negative x squared, we'll draw that first. So that's y equals negative x squared. What does the plus 4 do? It simply moves that graph up 4 units. And then we draw the same graph. So that's y equals negative x squared plus 4. So we probably should put some names on our axes here. Okay, so that's quadratic functions. You need to be very familiar with all of that and be able to do quick sketches without a graphic calculator, obviously.